Good morning and welcome to this session, which is part of the ACEC Civil 3D workshop. The title of this session is Exploration of Data Reference Corridors. My name is Mitch Lavin and I am part of the Wisconsin DOT Methods Development Unit. Prior to joining MDU, I was with WisDOT as well, but I was with the North Central region in Rhinelander, Wisconsin. I was a design and construction engineer using Civil 3D to design multiple projects, ranging in simple rehab projects to full reconstruction projects. I was with the North Central region for 6 years, where then moved to the Bureau of Project Development in the Methods Development Unit. I have been with MDU for 3+ years, working to implement Civil 3D in WisDOT by providing training, Civil 3D support Civil 3D support for our WisDOT users, and then also providing and reviewing the standards files that are developed for usage of Civil 3D in WisDOT. In this session, we're going to cover all things corridor data references. First, we'll cover the basics of creating a data shortcut and also creating a data reference. Then we'll cover some use cases, cross-sections and building surfaces, building second corridors from the data reference corridor, and this includes using the data reference corridor to extract feature lines, to use as baselines, and also extracting a feature line and using that as a target in the second corridor. And then one other use case that I thought of while developing this presentation of data referencing feature lines, or using the corridor data reference to data reference feature lines. Just a little workflow that might help other workflows out. Now, a quick disclaimer, the workflows I'm demonstrating today may or may not be the best practice workflows. They are merely just another way to do things in Civil 3D. So now we'll jump right into Civil 3D and start working at the basics of creating data shortcut references of corridors. We can check my tool space projects and look at the data shortcut menu and see that there's 3 corridors already sitting there. This corridor here in this drawing is named 51. And is not a corridor data reference, or a corridor data shortcut. So before we go and make that corridor data shortcut, we need to save the drawing to make sure it's up to date. Typically when you see the asterisk next to the name, it needs to be saved. Then we can go into Tool Space Prospector, right click on Data Shortcuts and choose Create Data Shortcuts. And when the data shortcut menu opens up, you can see the corridor is listed there. And we're good to go. Hit OK. And now the 51 data shortcut has appeared in the data shortcut menu. So now this corridor is available to be used in other DWGs. We can close this drawing and move on to the next part of the process. From the Start tab in Civil 3D 2020, we will click on the New Design Start to start a new design drawing. Once it's open, we can save the drawing wherever we need to save it. I'm going to move on and jump into the next part of the process, and I'm going to create a cross-section sheet. So I'm just going to save it to Sheets Plan and name it 090201-XS. Choose Save. Now when we create a data reference of a corridor, the corridor reference brings along all of the baseline objects that were used to create that corridor. For instance, this corridor 51 has a centerline alignment with a profile, and then 2 side road alignments and profiles. If there's an intersection, quadrants, the alignments that make up the intersection regions, such as the curb returns, those alignments and profiles also will come along. So when you're making cross sections, all we have to do to start out is just bring in the corridor. I can right click, create reference of the corridor. The name is where you use the same name. Corridor styles are what proposed. The corridor layer can remain the same. And as you can see, all the baselines that are associated with that corridor are listed here and will come along with the corridor. Hit OK. And zoom extents. And there is the corridor along with the baselines that were part of the corridor as well. So we have 1, 2, 3 centerline alignments. We have some alignments for the curb returns. Same with profiles as well. Now in the corridor reference dialog box, it stated a layer that the corridor was going to be placed on. I think it said P corridor 51 and the name of the corridor. But I believe I found a glitch in the software. As you can see, the corridor after selected is on layer 0, which was the active layer of the drawing. It comes in on any active layer that's set. So that's something I'm probably going to contact Autodesk about and just see if that is a glitch or if there's any issues with that. So as we see, we have the baselines, we have the corridor in here, and that's the basics of data reference in a corridor. Now it's there, it can be used. We can select it. The contextual ribbon is there. We can access the corridor properties. We can make corridor surfaces. We can view the section editor. We can do site distance driving, extract corridor solids. We can create sample lines, feature lines from the corridor. Basically do most things that are part of the corridor except edit it. You'll have to go into the original drawing to edit the corridor, but anything where you get information out of it or modify how it looks, style-wise, that can be done here. Now that we have the corridor data referenced into the cross-section drawing, we can move on and start working to create the cross-section views for the cross-section sheets. There are a few more pieces of information that we need, or objects that we need to complete the cross-section sheets, and we can get that through the data shortcut reference menu. If we expand to a space prospector and then go to the data shortcut menu, we need a few more surfaces. We need the existing surface. We'll put that on an X ground or X border style. The datum surface we will put on a datum border style. Final datum border. And top we'll put on a top border style. Okay, so we have all the objects that we need now, because when we data referenced the corridor, it also brought along the baseline alignments. So the centerline alignments for the side roads and main road. So we don't need to bring those in now because they're here, and we can use those as baselines for the sample lines. So from the Home tab, sample lines, you can select the alignment and update the styles. Exist as X ground. Final datum for refinement all datum. Refinement all top will be final top. And the corridor, the new recommended workflow is to use excess sheets with shapes. The background behind this is before excess sheets was recommended code set style to be used for the corridor. And then we would also show the datum surface, the base course surface, and the top surface. Now with the base course surface not a required deliverable, the base course surface really isn't needed for anything but showing perhaps the pavement structure. That can be accomplished now by using excess sheets with shapes. The shapes are turned on so you can see the shapes of the pavement structure and curb and gutter and such. So we'll use that as a preferred code set style. Choose OK and OK. And now it's going to create the sample lines. I'm going to do sample lines by range of stations. And I'm not going to go from the start and stop of the alignment. I'm going to pick my station range. So now I believe my datum surface doesn't go all the way. So let's see if I can find it first. Actually, no. I'm going to go to the beginning. And just do 55700. And we'll go to 58800. Left and right is 150 is good because I want to make sure I get all my information. Now, just but fair warning, I'm going from start to end. That's not typically what you want to do when you have intersections. Typically at the intersections, the sample line should be a little bit shorter. You come up to a match line somewhere in here, and then you have sample lines going on the side road for the 25 or 50 or 100 foot spacing that is required. What I mean is you just shorten the sample lines up to somewhere in here. Every intersection is going to be slightly different, whatever works for the stationing. And then build sample lines on the side road. But for this demonstration, I'm just going to do sample lines on the main road all the way through, and then use that information for display. So now that we have sample lines, I want to make sure I have my annotation scale set correctly. If we go through the Civil 3D knowledge base and go to cross sections and review to the cross sections how to control size and layout, we can see that there's a table in here about for what your maximum swath width is, and what annotation scale, what scale sheet is being used, and then the scale, the horizontal scale listed here has to match what the annotation scale is. So for a width of 300 feet, we can have the options of using 2010 or the 2020. And that means we also have to use the 20-foot annotation scale. So I'll change that to 20. 1 inch equals 20 feet. Now I can create section views. So making sure that I have the 2020 set. So that's what I want. Everything else is good. Make sure that I have 2020 on the template. And everything else is good. And here we have the styles which were assigned when sampling the objects. Pick a location to digitize the section views. Now if I go and look ahead in an area where there's curb and gutter, we can see the datum surface in blue, the top surface in yellow, and then green are the shapes from the code set style. And also the labels are from the code set style. I'm going to take this one step further and create some sheets. Now I already have a sheet set created, so I just need to go and create the sheets. In the output tab, we can do create section sheets, and all our objects are, we only have one option for each one. Next counter is good. I think we're starting at 1. That's good. We'll add that to an existing sheet set. And I'm going to go to my project. See Civil 3D projects. sheets plan. And there's my sheet set. Create sheets. It's going to save the drawing. We'll let that run. And as you see, the sheets have been added to the sheet set, and we have sheets now. We can just go and double check, see how those shapes look on the cross-section sheets. If I zoom in, I picked an area where the datum surface is not showing. There we go. And it has to be with the corridor surface. And perhaps I didn't update the refinement surface. But nonetheless, here we are. So we can see the refinement top, refinement datum, and then the corridor shapes in the cross-section views. So that was one successful cross-section sheet created using the data reference corridor. Now this is the new preferred way to go about creating cross-section sheets. The old way was to external reference the actual corridor drawing. The issue with that is that also when you're external referencing the corridor drawing, you're also bringing along everything else that is being shown graphically. Profile views, sub-assemblies, all the extraneous alignments that are being used for targets or other objects being used as targets, feature lines, polylines, and any other stuff that's sitting there in the corridor drawing. So that could make the cross-section drawing very heavy, unnecessarily heavy. So now with the data reference of the corridor into the cross-section drawing, we're only bringing just the corridor, which makes possibly the cross-section drawing easier to open if you have a big project, maybe less chance of corruption, so on and so forth. So this is definitely a best practice workflow, is to use the corridor data reference in the cross-section drawings. If we jump back into the agenda, the next use case possibly for corridor data references is to build surfaces. So if I jump back and just for a quick demonstration, I'm not going to cover this very much because Eric Yates will be talking about this at length in the session at 1 o'clock today, titled Corridor Data Shortcut Surface Modeling. I'll double check the agenda from ACEC workshop. The corridor data shortcut surface modeling. We'll talk about at length of creating surfaces from corridor derefs. But here in the section view drawing, I'm just going to show quick just the basics or the background. Number one, you can create corridor surfaces of the data reference corridor, just like if you have the surfaces in the original corridor drawing. You can use the Dynamo script that is now available with Civil 3D 2020 and WisDOT of creating corridor surfaces that works for deref corridor. And then the other thought is, from the contextual ribbon, when you select the corridor, there's also, you can extract feature lines from the corridor. So here we could do extraction of all, for instance, for all the top break lines or all the top feature lines that make up the top surface, and use those feature lines as break lines in the top corridor surface. There's another way of creating perhaps a top surface. So those are the concepts of corridor surface creation based on the deref corridor. Again, Eric's going to talk about that later on today. Now that we jump back into the agenda, we can see that we covered cross sections, briefly covered surfaces. Now we can jump into building second corridors. And what I mean by that is there's two different ways we could use a deref of a corridor as part of a second corridor. The first one I am going to show is using the deref corridor to extract a break line or extract a feature line and then use that feature line as a baseline in a new corridor. So in this theoretical situation, I've got a 2-lane highway heading north, and I've got a culvert pipe that's being replaced, and I need to build a lane shift for this culvert pipe. May or may not be, 100% accurate, width-wise and such, but the point is there. So the first part I'm going to do is I'm going to deref the corridor. So I've got some edge lines in here. Actually, I got a pavement file attached to show the edge lines of the roadway. So I'm going to deref the corridor in. We'll go to my tool space prospector to my project and find the corridor and create that reference. So now we see that corridor is there. And I want to use my edge of pavement as my new baseline. So if we go and zoom in and find our edge of pavement, this is the edge of shoulder. Here is our edge of pavement. And as you see here, when we do deref corridors, it get put on the P roadway subgrade shoulder point because that was my active layer. So I'm just going to go put it back on layer 0. So here's my EPS feature line. So I'm going to select the corridor. I want to extract that EPS feature line to be used as the baseline. So from the contextual Lavin, choose feature lines from corridor. I'm going to go pick the EPS feature line and then just hit enter to select that only one. It's going to grab both of them that are on top of each other. I'm going to deselect EPS shoulder pave 1 and then check this. We can put it on the site if we want to. We don't need to. Style's fine. Feature line layer's fine. Go into settings. I do not want to apply smoothing because it's going to, in a curve, I might curve it a little bit. And then name, I'm going to just name it something so I know what it is. EPS lane shift baseline or something. And I'll maintain the dynamic link to the corridor. So if the corridor changes, the lane shift will update. I'm going to extract that feature line. So now if I select, there's a feature line from the auto corridor feature line there. There's a corridor and there's the XREF pavement drawing. Now I'm going to select the corridor and I'm going to hide it. I don't need to see it anymore. Okay. So now that I have that feature line there, there's elevation assigned to that feature line. Now I can go, I have just a simple subassembly. Link width and slope goes out at 2% to a target and then cuts and fills to represent the lane shift. Just simple. Trying to demonstrate the concepts of how to use that corridor as a baseline. Now this could be useful in many different locations too. It could be used in construction staging. I'm doing a lane shift here, maybe intersections, cul-de-sacs, roundabouts, divided highways. There's many use cases that are available in this workflow of dereffing a corridor. Maybe others too. So now next step, I'm going to make a corridor. So from the home tab, corridor, create corridor. And I'm just going to name this one lane shift. The baseline type, I'm not going to choose a line profile. I'm going to choose feature line. And the site is on none. And as you see, there's only one feature line in this drawing, so it's automatically there. EPS lane shift baseline, and that's that auto corridor feature line. And I'm going to choose that lane shift subassembly or assembly with the target surface of my existing surface. Start station, I'm not going to go the full length because that goes for the full length of the corridor. I'm going to go somewhere in here. Let's go right up to where the lane shift intersects the shoulder gravel on the south end. Same thing on the north end. We'll go to the end. The target, the link width and slope subassembly, I want to target that. I think it's an alignment. Yep. Lane shift alignment. And then I don't need an offset because I'm just go 2% the whole length. I don't need a profile. Okay, and okay, we can maybe adjust the frequency, maybe 12.5 feet or something, something shorter. For the small corridor, it's okay. As you see now, we have built this corridor here based on that extracted feature line from the original roadway corridor. And that demonstrates the first concept of extracting the feature line from a corridor and using it as a baseline. The next concept of using a corridor derev and an extracted feature line is to use that feature line as a target in another corridor. I have an example theoretical divided highway here. I'm going to open the drawing. And as you see, I have already created a northbound corridor for the northbound lane. I do not think I have this corridor deref. Let me check. I do, yep. So the corridors are data reference from this drawing, so I can close this drawing and jump into another drawing where I'm going to model or create a corridor for the southbound side and the median. This probably could be useful if you have a long divided highway and you want to split the northbound southbound up a little bit so as to not have so many corridors in one drawing, perhaps making it a little easier to open and close, rebuild, so on and so forth. So I have derefed in the southbound reference alignment and then also created an assembly for the southbound side. So it's just a typical divided highway, 2-lane, 4-lane divided highway, and then I'm using the median ditch or berm subassembly in the median. Now I can deref the corridor for the northbound. As you see, I'm on layer 0 for the active layer. Corridor layer is showing P corridor 51 northbound. And the corridor gets put on layer 0. Anyways, we can work around that. So now I want to target this assembly is laying on or attached to the subgrade shoulder point or daylight sub on this shoulder subassembly. And I want to target the other daylight subassembly, daylight sub feature line on this side. So to do that, we can select the corridor, deref corridor, and extract that feature line. Select it, hit enter to select just that one feature line. And then again, we got to go into the settings, turn off apply smoothing, and then name it daylight sub target, median target, just so I know what it's for. Maintain a dynamic link, always checked, so that when the corridor is changed in the other one, this feature line will always update. So now we have that corridor feature line extracted, and I can build that corridor for the southbound lane. We'll do southbound as 51 southbound. Alignment profile is good. As you can see, I deref the northbound corridor, and the alignment is now available as a baseline as well. But I want to choose the southbound alignment profile with the southbound assembly. Target surfaces exist. Okay. Yeah, the beginning end stations, the whole length is fine. Frequency, I'm going to drop that down to 12.5. This is a short corridor. And now the targeting. I don't have any offset alignments for the lanes or anything. I'm just going to use what's preset in the subassembly. The only thing we do need to target is the median ditch or berm connecting point. And the way I have that set up, you can do either a mark point or a width and elevation line. And that's why I have it set up for the subassembly to read a width and an elevation from a profile or a feature line. So the ditch width is fine. I set that preset. The connecting width, point width is what I want to assign. I'm going to grab the feature line. I'm just going to select that extracted feature line there. Okay. And then now we got to assign the elevation as well. Connect point elevation. Assign, grab that feature line. Okay. And that's all we need to target for this particular case. Typically, you'd probably want to target some offset alignments and such for the lanes and shoulders, but I don't have that here in this case. Choose OK and OK. And it took a little bit to be built because I set the 12.5 feet, which 25 probably would have been okay, but as you can see, the ditch was connected right to that daylight sub feature line on this end. I don't know if we're going to be able to see the other corridor. If there was a surface there, maybe we would be able to, but we'll do a section editor anyways on that frequency. Yeah, it doesn't show it, but you can see it work. We can do a 3D view and just see what it looks like. That would make it a little bit easier to see. So if I select the corridors and then do a view orbit, you can see that now the ditch comes down and then connects into that extracted corridor feature line on this side. And now to demonstrate the corridor surfaces, I gotta make two viewports here. So I can access the subassembly. I am going to use the Dynamo script included in Civil 3D 2020 to create the corridor surfaces. I'm going to select the first corridor, the northbound. Make sure I get it. Okay. And the naming is good. Top feature line codes are coming and use the most used feature line codes. Same with the datum. Build the corridor, hit play to run it. Cool. Now I have to select the other corridor. Now I believe that there's some links, some point codes in here that aren't normal. So in median ditch and out median ditch. Yep. So I need to add those to the top. In med ditch, out med ditch. I think that's how they were. In med ditch. Out med ditch. And we gotta do one more, it's median. Okay, hit play. Alright, I'm going to pause the video while it rebuilds. It'll take a few seconds. So now as it finishes rebuilding, the corridor surface is getting built. And it may not show up right away. We do a regenerate graphics. There they are. We can put it on a shaded view. So we can see the top surfaces. So that worked pretty good actually. So those are the basic concepts of extracting a feature line and using it as a target. Again, there's many workflows that could be done using these kind of concepts of extracting feature line. You know, they could be used in construction staging, lane shifts, intersections. You know, there's some possibilities with intersection quadrants and using two corridors when modeling an intersection. Perhaps cul-de-sacs could be used somewhat on this workflow of extracting a feature line and using the relative feature line connections and such with the standard sites and feature line capabilities. Roundabouts, possibility for extracting feature lines and using multiple corridors when modeling a roundabout. And then, as you see, a divided highway could work as well. The last part of the agenda is to review a possible new or a workflow enhancement that may or may not help certain situations. But there is a possibility to use corridor data references to data reference feature lines. So I'm going to go through and kind of just explain the basic concepts behind that. Here is a curb ramp that has a lot of feature lines. It was used for designing a curb ramp. And I'd like to perhaps use these feature lines elsewhere. You know, this may not be the best case scenario, but it demonstrates what's being needed. Maybe there's a site grading that you need to access those feature lines in another drawing. So the basic concepts here, workflow, is to just create a corridor, and I'm going to name it feature line dref. And actually, I think I already have one in here, so I'm gonna have it in here. So I do have a corridor, so I'm actually I'll just leave that one in here. I'll create a new corridor. I'm going to freeze the other corridor. Okay. Feature line dref 2. And the baseline, I'm going to add feature lines from a site, and I can just go work through all the feature lines. I'm just going to work on the first curb ramp, so lower landing 1, Okay. And then I'm going to go into that corridor and add more baselines. Add baseline, feature line, ramp 1. Sidewalk front 1. I'll add a few more. Don't need to do them all for this demonstration. Sidewalk back. So if you have a lot of feature lines, it might take a little bit, but once you have it all connected, it will be live. Hit OK. And you should only need to just create the baselines. Save the drawing. And then go into the data shortcuts and say create data shortcuts. And then I can select the feature line deref 2. Now if I go start a new drawing, I should be able to deref that corridor in and then extract those feature lines. So once the drawing's open, you go into corridors, feature line deref 2. So what it did now is it brought in the baselines as alignments. Let's see if there's profiles assigned. Let's just create a profile view and see what it looks like. Yeah, it did. Brought in profiles too. So when you deref the corridor, now you have alignments. That's one way to do it. The second way to do it would be to expand the corridor deref. So if I go into the corridor, if you want to just extract the feature lines, and there's a little bit more work needed to get to that point. So if I go into this feature line deref 2, you need to add regions. And all I have for an assembly is just a marked point assembly. So it's just an assembly with a marked point. And then I can go into the corridor and in each one I can add a region for all of them. Okay. Now here's that corridor. Let's see what's selected. So then it actually shows up in model space because there's a feature line running along that corridor using that assembly. I'm going to start a new drawing. I've got a second corridor. Did I freeze it? I think I froze it. I have a second corridor where all these feature lines for this curb ramp are part of that corridor. Okay, you can kind of see the preview of the highlight. So I'll start a second new drawing, and I can data reference that corridor that has all the feature lines assigned with the baseline and the region with that subassembly or the assembly. Choose create reference. It's going to bring in all the baselines again. It's going to do the same thing. All the baselines that we assigned, it's going to bring in alignments and profiles. Here, once it references, you can zoom extents, and you can see all the alignments are brought in. I'm going to just delete all the labels. I don't need any of those labels. And I think we could probably freeze all those layers too. Let's see if that comes in on the layer. Those alignments, yeah. So all those alignments that came in, they come in on certain layers. So I can freeze all those layers if I want. And now you can see the corridor is sitting there by its lonesome. Feature lines are sitting there, a part of the corridor. And now I can extract those feature lines. So if I say feature lines from corridor, and click on it and then choose all those feature lines are get extracted. Naming isn't going to match, but the feature lines are there. So now we have feature lines that are from that corridor. So essentially, we kind of derefed the corridor, the feature lines. It's not layer or object by object, but the concept is there. If you want to use the alignments, I think that was alignments sitting here. The alignments append to the naming, upper lining 1, but the feature lines don't when you extract them. So there's a couple options of how you want to make it work. The alignments come from the baselines, and the feature lines are extracted from the corridor after adding a region. But it is a concept that may improve certain workflows. And if you feel like responding or chiming in and during the question period of, maybe where would this workflow work? Because there are options, or there's a way we could perhaps build a Dynamo script that would automate this process of creating the corridor and then extracting the feature lines, so on and so forth, and perhaps maybe automatic naming and such. But we don't want to put the time and effort into developing it if there's not much use cases for this workflow. So if you have any ideas of where this might be useful, send me an email or let me know in the chat questions or the questions and answers session coming up, which I will jump into that right now, I suppose. So in this session, we talked about basically corridor data referencing, looked over the basics of creating the data shortcut and then creating the data shortcut reference, and then some use cases. We looked at cross sections, surfaces, building second corridors by extracting feature lines, using those as baselines, and also using the extracted feature line as targets. And then we also looked at the possibilities of using feature lines and data reference corridors to essentially data reference feature lines to other drawings. So the big question for you guys today is, do you have any questions? If you want to give me a contact, or my contact info is there, my email, send me an email if you have any questions, or if you have any questions right now, my email is also on the handout for this session. I guess we'll open it up for questions now. Thank you very much.